In the previous lecture video, you find out how to get the division and in Egyptian method. But one of the problem for that was we are not going to get nice quotient like this and having 0 for the remainder. In most cases, when you take any division, we might get the non-zero divisor. So how can you handle that? So that was the issue, and you can imagine, right? It's going to be a very difficult question for them. So they made very clever idea and used that method, and which requires kind of unit fractions. Once again, they didn't use the positional number system, which means just using small number of symbols is not enough. They have to invent certain symbols to matching with certain fractions. But those fractions must cover any types of fractions, right? So we are going to talking about that the symbols of those fractions later, but this is the idea how they calculate it. So let me just use the 6 divided by 7. Okay. Let's just imagine. Then their method is exactly the same as before. 1 is matching with 7, but instead of doubling, how about take the half of it? So 1 goes to 1 half, then 7 goes to 7 half, which is 3.5, and try to get that divided 6, right? So 3.5 is not 6 yet, which means we need more numbers. So when you take the half of this line, we are going to get 1/4, but half of that is not kind of 7 over quarter, but let's just imagine this way. 7 over half is same as 3 plus 1 half. It's much better, and eventually we are going to get 6, right? So it's not, it's less than. Then we take the half of that by using this one. So it's 3 half plus 1/4. And that is also can be changeable to 1 plus 1 half plus 1/4, right? So whenever you got the integer values, you just got the integer values and write down. And when you're adding this much all together, then it's 4 plus 1 plus 1/4, which is 5 plus 1/4. So it's still less than 6. So it's not equal to 6 yet. Then we have to further. So take the half of it again. And of course, using half of that notation. So it's 1 half, 1/4, and 1/8. In this case, no more integers, so we can just accept that. But when we're adding up this much, we already have 5 plus 1/4 as the sum of the up to the previous line. So when we're adding this result to 5 plus 1/4, we have 5 plus 1 half plus 1 half plus 1/4, right? So it's 6 plus 1/8, which is greater than 6, right? We want exact same number is like 6 here. So we realize this is not necessary, okay? Because whenever we're adding them, we just got it. So we have to just stop there, and there is another group. Next group is because we are taking all the division by 7, right? So these are just kind of doubling by 2, right? So we just take the division by 7. So 1 goes to 1/7. Then 7 goes to 1, right? Then starting with this and take the half of it again. So 1/4, I mean 1/14, and that goes to 1 half. So we don't use this one because it's greater than 6. So we still have this much, right? Then adding with that result is 5 plus 1 half plus 1/4. This is still a little bit smaller than 6. Then go further. So half of that is 1/28, and 1 half goes to 1/4. So if we add these two results together, then it's finally 5, 1 half, and 1/4 plus 1/4 is 1 half, which is exactly 6, right? So meaning is, when we adding these four numbers, we are going to get 6, right? Then the corresponding numbers should be the result for the divisor. So we got adding up to the second column 6, then the first column will giving us 1/2, 1/4, 1/14, and 1/28. That should be the result of that division. Sounds strange, but look at here. In our number system, what we are going to get if you divide 6 by 7? By doing this way, we got 0, uh, 8, right? 56, then 4, 28, 20, 2, 6, then it's repeat, right? After that. So, but anyway, what he had, for example, is this much, right? But the meaning of that, let's just talk with just that much. The meaning of this one is actually 8 of 1/10, right? Plus 4 of 100s and 2 of 1000s, right? And keep doing. So this is exact same formats like we have over here. The only difference is in our system we just use powers of tens, right? Because it's decimal notation for positional number system. But Egyptian numbers are not like that. So this kind of denominators is not multiple of tens, but anyway, the numerators are always 10, always 1. So that's called, they are just the unit fractions. And Egyptian number system, and the result is less than 1 for the kind of decimal proportion, then actually they use this sum of unit fractions. They call it unit fractions, and they make the symbols of those unit fractions. And they actually kind of figure out that any decimal number can be written by sum of those unit fractions. And this is how they found it. It's the result. So let's just do example asking a very similar question like that. Okay. Okay, here, let's just take the division of 45 by 8. Then look at here, yeah, just no matter what, 1 is matching with the divisor, 1 and 8, and 48 is still greater than, 45 is greater than 8, so we have to use the doubling method to calculate, right? Then when do we have to stop? When this second column result is greater than 45, right? Then we just stop there. That's it. Then we start adding here, right? So 32 with 16 is 48. Ooh, that is already greater than 45, which means what? We cannot adding like this. So we have to skip that and adding with this one. Then it becomes 40. Okay, good. Which means what? When you take the division of 45 by 8, the integer part of our portion is 40. And the others are fractions, the decimal part. Then to get the decimal part, take the division, right? I mean, take half of it. So 8 goes to 4 and take the half of it. So now, at this moment, how are we going to figure out this? What is the leftover between the given number 45 and the sum of those is 40, is 5, right? So somehow we have to get that remainder, right? So when you take the real division in our number system, so it's 5, right? So 40 and 5, right? So this is matching with that number, and 5 is from that subtraction is the leftover, right? So 45 minus 40 will giving us 5. So from this portion, we have to somehow make this 5. So by taking half of the previous line, starting from here like that, 1/2 and 4, and 1/4 is 2, 1/8 is 1. Then that's the part to be step. Okay. And which numbers makes 5? Matching those two, right? Then corresponding numbers are like that. So when you're adding them, we need 5, which means not these two. And from the first column, we have 1/2 plus 1/8. So altogether, 45 divided by 8, it becomes, adding up those integer portion is 1 plus 4, right? And plus 1/2 plus 1/4, right? So it's kind of exact same procedures, but in the previous example, we got the 0 for the the remainder. Then all we need is just corresponding those numbers, right? But if it's not 0, then we have to take care of by taking half of these procedures and just write down corresponding numbers, which makes that sum makes that remainder. Okay? So of course, this one should be written by 5 plus 1/2 plus 1/8, right? So we don't know how to write, we don't know what the exact symbol for that, but this is the Egyptian method, and they just write down that way, right? Because their number system is addition method, which means put down the symbols as many as they need. So this is how you can calculate the division by Egyptian method.